hand over to Helena.
Okay then. Thanks, Thomas, for the introduction, and welcome everybody to the first webinar of this webinar series. We are in the introduction to EESSI 1, and we have many other topics for the following weeks, so we invite you to register through the same link you already used, but here's the QR just in case you want to check it again. You can ask questions through the EESSI Slack. You can join through the easy.io webpage. You will find a link there, and you can search for the Webinar Series 2026 YouTube channel. And there you can ask questions, maybe comment anything like, I don't know, you cannot read what I'm typing, or I'm too low, or I'm talking too fast. Please feel free to comment it. There are moderators there that will help you. So with this being said, what if you no longer have to install a broad range of scientific software from scratch on every laptop, HPC cluster, or cloud instance you use or maintain without compromising on performance? Well, it sounds like magic, but the European Environment for Scientific Software Installations is here to do that. My name is Helena, I work for EduIT now, and with me in the room we have Thomas, Kenneth, and Richard that will be moderating the session. And so what is our motivation? Mainly because of the explosion of the available scientific software. Like there are like millions of packages of bioinformatics, AI, physics, whatever. And I can assure you from a HPC support perspective that software installation requests just grow and grow and grow every day, and there's just not enough people to leverage that. And also not only in HPC clusters, but also in the cloud, or maybe in some CI pipeline, or any kind of compute continuum environment you can find. And not only different environments, but also different processors. So there are many different architectures right now in HPC machines, or again, in any kind of environment. So we have Intel AMD, but we also have ARM machines, and maybe even RISC-V. So what do we want to do with EESSI? The main goal is to provide a uniform software stack, and that means that you would find the same exact software everywhere, and everywhere is everywhere, again, regardless of the environment or the architecture you might find in the machine. And obviously without sacrificing performance, because we do high performance computing, and performance is part of the equation, so you cannot leave that behind. Because you know that usually when you compile something for a generic architecture, like when you use a container or some kind of environment, you are losing performance there. And of course, as I mentioned, to avoid duplicate work, we are many HPC support teams out in the world, and we are all doing the same constantly, every time, everywhere. So it just duplicate work that could be avoided. And we have tools, of course, like EasyBuild or SPAC, but they are not enough anymore. And what we want to do with EaSSI is not just share the recipes like one would do with EasyBuild or SPAC, but also like streaming the binaries itself. So we are all working together through a shared software stack. And with this, we help facilitating HPC training or development of scientific software, but more on that later. So as I said, if you compile for a generic architecture, you are losing performance there. The one size fits all does not apply to software. And here we have a graph from, for example, GROMACS. You can see that the performance, if you try to install it from repos, it's way lower than if you compile and run it on the architecture it's meant to run. So demo time, because I said things that sound like magic, but I promise you that it works. This is my laptop. It's not an HPC cluster, as you might imagine. So just to show you that it really works everywhere. So it's a very basic and even kind of old Intel machine, nothing fancy here. It's one i5, so it's again a really kind of old Intel, not a high performance one. And release, it's an Ubuntu. Easy, it works out through kind of environments, and that includes the operating system too. It would work anywhere. So this being said, if I now do a module avail, you see that I have lmod installed, but that's because of another reason. But I have nothing installed here at all. It's completely empty. So what I'm going to do now is to initialize EESSI. Wait. And I have it on my history because I do it quite often. Okay. Actually, I don't have it on my history, but that's okay because then I can show you the EESSI documentation. So we have a really nice documentation. And here you can find like all the instructions in order to access EESSI. I have it installed natively. This is what the steps you would follow if you want to, if you also have a native installation, but it doesn't have to be like that. So I'm initializing EESSI, and we will see in the prompt that now will appear that it will auto detect what kind of machine I have. See, it detected that I have an Intel, as I said, Haswell, which is this pretty old architecture, and an x86-64. And it didn't identify a GPU because, again, it's my laptop, so I don't have any of those. And if I now do module avail, we have magically now all these modules available for us, well, for me. And I'm going to load whatever to show you. So for example, Gromax, I don't have it here, but if I know to whatever, oops, sorry. Yeah, we'll look, it's case sensitive, so. Okay, if I now do any help, we can see that it prints the help from Gromax. So nice, it works. And I can explain you how and why it works. So this is the backup slide, in case you want to try it yourself later. But again, it's in the documentation, so you don't really need to check this one. So how does it work? All the software installations that we have there available are streamed via CernBMFS, which is an open source software that I will introduce to you later. And again, it's built to be independent from the host operating system. You see my laptop, it's an Ubuntu, but later we will try it in a different kind of machine, and they are Red Hat, and you will see that it also works. And all of these binaries are optimized for specific CPU generations and GPU types. I didn't show it here, but if we scroll up, you see that it's selected also, like it detected here my machine, but here in the module selection, it also automatically selected the one that's better for my laptop. And not only CPU, but also GPU too. And what's the magic underneath? So this is how EESSI is implemented. At the very bottom, we have the machinery, the pure iron, which is the hardware, and we can have an Intel machine, AMD, ARM, and now also we support RISC-V. And on top of that, we have the host operating system. This is not part of EESSI. This is what provides like the network, the GPU drivers, the resource manager, and this kind of stuff. And then on top of that, we have EESSI itself. And on the bottom, we have the file system layer. This is like the infrastructure to distribute the binaries, but not the binaries themselves. This is really important, and also more on that on the next slides. And then sandwich on the middle, we have the compatibility layer. Maybe you heard about Gentoo. It's a Linux distribution and has a really nice feature, which is this prefix kind of installation where basically you install the whole operating system. Well, the whole operating system, but in a minimal version inside a particular prefix on your system, which means that you have a container without being a container. And this is what levels the ground to make EESSI work across all operating systems. because all the applications that we compile on top are inside the point to the compatibility layer. And then on top of everything, we have the software layer where we have the binaries themselves of the applications. And as I said, all of them are optimized. Also includes all the dependencies. ArcSpec is the library that detects the machinery underneath. And we build the software through EasyBuild and we expose it via LMOD. And all of this is tested via reframe. And I need to drink water, so 1 second. So about the file system layer, it is powered through CERN-BMFS, which is an open source software developed by the CERN, as you might guess from the name. And the way it works is that you have a Stratum 0, which is like the central server, and it's the only one that's writable. And then you have all this sphere of Stratum 1s that they are mirrors of the Stratum 0, and they cannot be written. Like the only one that's written is Stratum 1, and that information is replicated down. And then to leverage the accesses to the Stratum 1s, you can set up a proxy. It's optional, but we really recommend it. And in case you want to have EESSI on your own HPC center, we recommend to set up a local Stratum 1 and proxies too. And they just act as a mirrors of what we have in the Stratum 0. And that's it. Then you can access through these proxies to the repository. It doesn't matter if you're in an HPC cluster, on the cloud, on a pipeline, on my laptop, on a Raspberry Pi, on a VM, whatever. And what we have exactly for EESSI, it's a central server in the University of Groningen, and then some mirror servers across the world, some in Europe, some in the United States. And then the proxy servers, we have a couple of them, I think, but again, it's more recommended if you have a local one and then access to our ones here. And if you're interested in how does it work, we have a webinar. It's actually one of the topics of the webinar series, and in 2 Mondays you can have it and listen about it and the best practices and tutorials and everything. So we recommend you to attend to that one too. So about the compatibility layer, as I said, is that I can do prefix in a very particular path. And this is what provides us the standard Linux tools and libraries. So again, it's the libraries, not any kernel feature, not any driver. And they are also built for a certain architecture to make sure that it works everywhere. And the conclusion is that it levels the ground for different client operating systems. And I also want to show you live about it because it sounds a bit abstract when one talks about it. So let's see if so what I'm going to do now is to show you. So .easy.io. Okay. Versions. I'm going to show you. Oops. The last one. No, I mean the 2023 one. So I'm going to show you this one. Wait. Sorry if I'm not the best typer today. Yesterday I was rock climbing and my fingers are a bit cooked. Okay, Linux and X6. So as you can see here, this is like a very bare minimal but recognizable distribution of Linux. And you have like the bin, the /bin, /etc/lib/whatever. And I'm going to show you the contents of the lib64. And if you are familiar with Linux environments, you might recognize some of these ones, like the very famous libc, or the interpreter/linker, or the libm. And what I can also do is try to show you. So we were using Romax. I'm not sure if it will work with this. No, okay. So we'll show if I now go to the path of GrowMax, for example, and I show you how it's through LDD, you will see that all the binaries we just saw before, like the libm or the libc, are pointing to the compatibility layer. So this is how it works underneath or under the hood. It's not magic, it's just being kind of sorted and know where everything has to point. And with this being said, we are doing good on time. I proceed to the software layer. So again, this is where all the binaries are streamed. And all of them are classified and organized according to the architecture they are built for. And the ones built for GPUs are under the /Axel subdirectories. As I showed you, the glibc in this kind of libraries are pointed to the compatibility layer, not from the host operating system. So in that case, my laptop. Again, this is built through EasyBuild and exposed through Elmode. And you don't have to worry about selecting which one is the best for your machine. So Easy will do it itself. And it looks like thunder, so I hope everything is fine. So what system architectures are we supporting? So the different generations of the x86-64, this means Intel AMD mostly, and then ARM 64 bits. And RISC-V is now already available, but more on that later. What does that mean? That basically all or very big part of the EuroSPC machines are supported. So the A64FX works in Eucalion, and we also have builds for the NVIDIA Graces. So Jupyter, which is the first exascale in Europe, once it's in production, you will have the binaries already there available for you to use them. And again, it's not only EuroSPC machines, you can also use your laptop, virtual machines, cloud instances, whatever, Raspberry Pi also works in there, so up to you. And also, right now it's supported NVIDIA GPUs, and the AMD GPUs, it's a work in progress, but a really cool thing you can do is that you can mix builds for AMD CPUs plus NVIDIA GPUs. These are the available combinations. I'm not going to read them all, but the good thing is that it supports until the compute capability 120. So pretty modern architectures. And Easy does not only support different architectures, but also different interconnects like InfiniBand, OPA, this kind of interconnect, because that's also a bottleneck. And just as I mentioned before, the goal is to support the architecture for all EuroSPC systems, and that means the ones that already exist and the future ones, just as Jupyter, for example. This is a summary of the releases and repositories we have. So what I just showed you through my laptop is the production repository, and in particular the old one, the 2023 one, which has been the default one since June 2023. We have more than 1,000 software installed there and 6,000 unique packages. And there you will find software that's compiled with the tool chains until 2023, which means that it's versions from GCC up to the 12.4. And now there's a newer version, the 2025.06, which is already available, but there's quite an effort to add more software. And then you will find 700 plus software installed and 400 unique packages. And the software there, it's compiled through newer tool chains, and you will find applications compiled with GCC versions from 13.3 up. This is for the production ones. If you try to scavenge the documentation, you might find something about the pilot one, but that's dead and buried, so we don't care about it. There's the RISC-V one, also, which used to exist separately, but now it's part of that .easy.io, which is the developer repository, but I will talk to you about that later. And I need to drink water again, so I let you think all that information. This is about the architectures we support right now. We have the two big families, the x86-64, what I just mentioned before, the Intel plus AMD. And yes, we have generic builds, but we have all the software optimized for all of these families of AMD and Intel architectures. And for the Arch64, we support these ones. The ones in pink are ones that we used to support, but not anymore because they are oldish now. And for NVIDIA, we support the gray ones, which are quite new. And then we have here separately the RISC-V ones. And this is for GPU targets. Again, for the old repository, it supports up to CC90, and for the new one, you have until CC120, which is the latest NVIDIA machine, well, architecture, so really nice. And the AMD, it's a work in progress, but it will come for sure. This is a very nice graph of the evolution of software installations available in EESSI. This is for the older repository, which has quite some steady growth, and lately we've been focusing more on the newer repository. And again, there's an ongoing effort to add more software, but quite a good start, I would say. So that's really nice, but on which machines is it already available? If we talk from the very big UHPC machines, we have it already on the very big ones natively through Vega, Carolina, and Deucalion. In Mare Nostrum, it's definitely there. It uses another kind of way under the hood, but it's there. Also through another kind of setup through Lumi. It's not super natively, but it's there again. Also on Discover and Meluxina through other tools that are explained on the webinar next week. And then there are works in progress like Meluxina. And it will be available on Jupyter for sure. The work is there already in place. We just need the machine to be fully in production. And it's for the super big machines, but you also have it available on some other tinier, smaller European systems. There's quite a long list. You can see all the machines which is available in this link in our documentation. And we are really happy to welcome new systems. So if you have it available on your cluster and you want to make it publicly available, you are more than welcome to tell us, and we will just list it there. And this is a visual representation of what I just said. And you can see that for the biggest UHPC machines that are operational right now, EESSI is already there. So we got pretty much covered everything. So what's the conclusion with all of that? We have our really nice unified software stack. And this is automatically streamed to your HPC systems and whatever you might want to. So more details about the NVIDIA GPU support. It's in place for both of the repositories, and you have a detailed documentation here in our in this page. The problem with this is that, you know, CUDA, it's kind of a proprietary software, so you cannot redistribute it so easily, but you can redistribute the runtime libraries. So the solution here is that there are two scripts provided via EESSI that you just run and the magic is done. Like these scripts will find the libraries from the host and inject it through EESSI, and this way you will have GPU-enabled software. And this is one of the available CUDA software you can have in EESSI, like the CUDA samples, GROMACS, Espresso, LAMPS, etc. And the thing is, as you see, you can have the both versions of them. Like I just showed you the GrowMax, which is only CPU, but you can have the GPU enabled version of this software. So it's not like you only have it on with CUDA. You can have everything. And there's work in progress to bring these superstars of CPU and GPU software ongoing. And as we do really exhaustive testing to make sure that everything works, this is a bit slow, but it's fine. Like we are working on that, and it will be fully supported soon. And something nice we wanted to show you, which is a bit recent, it's the, well, not recent, but I think we never showed it on any other presentation. It's the status.eeessi.io, which is just, we can also show it here. Basically, this is to make, in case that something is going slow or you have some kind of error, you can check through status.eeessi.io if all the sync servers are nice, if all the repositories are up and running, if the mirror servers are okay. So just for you to know, you have this available publicly for you. And in case if there's some maintenance, you can also know from here. So now I will do 2 demos in one, and I would need the slides. So let me change my setup a bit. So I will show you both how to get access to EESSI in the way of installing it natively through your machine, and other ways to use it. So what we have here, it's another kind of machine. Whoops. So again, so I'm not lying. Here we have another kind of machine. It's also an x86, but this time it's an AMD EPIC CPU. It's not an Intel machine. And here we have, here we see that it's a Red Hat Fedora type of Linux, so completely different from the Ubuntu before. And here I have a slide on how to install natively the EESSI, but oops, not this one. Well, doesn't really matter. It's better if we see it from the documentation, so then you can also follow it yourself later. Okay, I'm going to install it natively because thankfully I'm the administrator of this machine, so I can use sudo, but that could not be the case for you, but I will go into other ways to access it later. So I already did the first step here because I wanted to check that everything was fine, but basically I just executed this command before the webinar started, and I'm going to proceed with the second one. So sorry. So this is a live demo, let's see. Everything will be fine, but I might be nervous. And it might take a while. Again, don't be upset if you're not the administrator of your cluster or whatever. Like, there are many other ways to access EESSI that don't require these kind of permissions. So now I'm going to execute this one. Super fast. And now we need to set up these 2 variables, but it's, sorry. But it's just 2 variables for the CVMFS configuration. It doesn't really has to do with EESSI. And then the last one is just to make sure that everything is fine, which it seems to do. So now if I go to Stern BMFS, don't be scared because it works like, it happened to me the very first time I tried to install Stern BMFS by myself, that I saw nothing here and I thought, what's happening? And it's because it's on the, like, you have to ask for it in order to get cached on your machine. So now you see that as I went straight to the repo, now it shows. So if I now do the same thing as I did on my laptop, which I will copy from here again. But this time I will maybe, no, yeah, I will do it with the old one so you can also see that it detected that I'm in an AMD machine, it detected the microarchitecture, and it also detected that I'll have an eGPU. But if I now do a modulo level, I will see the, okay, so maybe it's nice for you to see, and it's raining. If there's too many background noise, I will just switch the microphone. Okay, so when we say uniform software stack, it's that if you read carefully, you will see that the software you see here, like Upsail, EC Pipe, AIDA code, blah, 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 it's the same one you can see here. Same version, compiled with the same toolchain, everything. But I'm into different machines. So this is the AMD Zen 4 binaries, and this is the one from my Intel Haswell. So really nice, isn't it? And this is for the part of the native installation. But if you don't, if you are not the administrator of your machine, don't worry, because here we have another machine where I'm going to show you. Let's go again. This is quite a different one because this is an Arch 64 machine, an ARM processor, but the operating system, it's the, again, a Fedora. And I forgot to show you before that here also we don't even have Elmod installed. It's just a plain VM we spin up for this webinar. The thing, what I'm going to do in this one is to access EESSI through a container. And the way to do it is because usually, if you're in an HPC cluster, most probably you will have access to Singularity or Obtainer because they are usually provided by the support teams in there, which I have here. And I actually had troubles trying to install Obtainer for this architecture. I had to do it from source, but don't worry because you don't have to. Again, this is usually provided by your support team. What I'm going to search here because I want you also to see. In case, so it's usually not this one. Okay, I don't want to be searching it for a long time, so I have here cloned the software layer scripts repository we have in EESSI. And what you can do here is just run the EESSI container script. Again, it only works if you have installed already the Obtainer Singularity one. And this will do the magic for you, like it will pull the container and it will start it. It might take a while. So let me find where we have exactly in, here. So this is what I just said, the version supported, you git clone our software layer scripts one and enter here and just run the script. And again, it might take a while. I live in a village, so my internet is also a bit slower than probably yours. But now we have it ready. Don't be scared now, because if you do module level here, you will see that's also probably that's not available, but that's because we didn't init EESSI itself. So we started the EESSI container, but we didn't start EESSI inside the container. I hope I'm making that clear. But one would see that it has CERMIFS available here. So what we can do again is to source EESSI just as we did before, which I will try to copy from here. Blah. And note how even if we are inside the container, it detects that what's the machinery underneath. And if I now do module avail, we have again easy available. And with again the exact same software we've seen on the other machines, this upsell, ACP type, whatever, it's here and with the same versions, with the same tool chains and everything. So nice, magic and working, just makes your life much incredibly easier if you have to switch machines constantly. Very good. So these are the backup slides I had just in case. And for example, just as I initialize it on my, like interactively, you can use it through a batch script. This is an example of a Slurm job script where we initialize this in. Like you also have to really initialize it there too. And from once you have it ready, you can just module load the whatever software you might need and just use it as you would usually do. And a particularity of this example is that one has to add the constraint of easy because this is, for example, for this is for the Lumi supercomputer, where they don't have. I mean, they have easy available, but you have to specify it through the job constraint. So we also really invite you and encourage you to please first look at the documentation from the HPC machine in particular and make sure that you don't have to do any extra step for using easy, although you might usually, you would have to because most of them have weird setups, but okay. So, okay, this is wonderful, but what if the software I need is not provided by easy? Well, you have many options too, so don't worry. You can build it locally on top of Easy with Easy Build, which is what we recommend because this is very much tested and working. And I also do it a lot for our clients and everything. We have, I'm not going to delve into this too much because the webinar for next week is actually on how to build on top and contribute to Easy. So we encourage you to attend next Monday. Please come. So you can build on top of Easy with Easy Build or without Easy Build, which you can also do it, but it's not that much tested, so it's up to you. It's a bit risky, but it's nice. And you are not contributing anything if you do that. You are just taking like the dependencies from Easy and using that, so you save time too. But in case you are super happy and you want to contribute back to Easy with this software you just built for yourself, contributions are more than welcome because after all, this is an open source project. So you can just look at our documentation and try to, well, we have a contribution policy, so read that carefully. And we wait for your PRs from now on. It's up to you. This is what I just mentioned. And what if you don't like Easy Build? Well, that might be a conflict of interest, but you can also use a spec to build on top of Easy, but take that with a grain of salt because there's work in progress to make sure that's fully supported, but for the moment we have a proof of concept that you will find in our blog here. You can read it to get hints on how to do it and again, then you are on your own risk to try it, but it's possible. So what if we want to add software to Easy? You are a contributor and you open a PR to the Easy software layer repository. And then there's a bunch of reviewers, some of them in this very webinar, which will take care of it. So use a contributor. If you create a PR, then you have already done like 90% of the work. Then you just have to wait until some of the reviewer submits a build job. So we have this very super amazing heterogeneous cluster in the cloud. And we have a bot that instructs to make the build of the PR in this cluster. So it submits like a very big batch of builds and they are built on the nodes automatically and everything is tested through Reframe. And these installations are signed, and this goes into an S3 bucket, which are picked by a cron job. And that goes to stratum 0, opens a PR into the staging, and then the reviewers also, if they find that everything has went well, and that means also checking the signature here for security reasons and that the builds don't have any error and any warning, then it's deployed finally into the EESSI production repository. So again, if you want to contribute, the the worst part is just, I mean, it's not the worst part, but the only thing you have to do is creating a PR, and then the reviewers do the rest. So don't be afraid of contributing to EESSI. It's really easy too. So about this bot, it's fully automatic, but it requires of a human instructing it, which means that, okay, it's better with the example here. So let's say somebody, this is a screenshot from a real PR. So one of the reviewers said, bot, please build for this repository under this, this is the cluster we have for these architectures, and it lists the architecture it wants to build for. And then the bot submits the job, and then it reports back where it built it, the directory, and if everything went fine, like in this case, or if something went wrong, he would say like failure, click to see what happened. And then it's also the reviewer's job to inspect the build and see what went wrong and see if it can be fixed, or maybe ask to the contributor again if something needs to be fixed. So this is a whole completely big CI infrastructure of GitHub runners and self-hosted runners running on this cloud infrastructure, but we also have the bot running in some of the HPC clusters we have access to in real clusters, physical ones, running its own bot instance. And again, it's the bot does the work, but it's the repo owners who define the logic and what to do and how. So it's a very big thing. You can check the document, the bot has its own documentation, and you can check it here. You're invited to read it. And software testing is a really important part of EESSI because you are putting binaries into production and for a lot of people to use it. So we take care that everything is properly tested. And once you are building, if you are building with EasyBuild, there are some sanity check commands that are automatically run, but there's also the whole test suite of EESSI. So these are some tests for the available software in EESSI, and they run on different machines periodically. And that can be like daily, weekly, or however you want to. This is like running benchmarks constantly. And let me mute this thing. Okay. And it's also better if I show you directly, because this is displayed in the EASY dashboard. So if I now go to dashboard.easy.io, here one can see the results of the benchmarks that are being run. So you have this empty monitoring panel, let's say. One has to select the EASY group. And here you will see the list of software where do we do periodic benchmarking. And let's select, I like Gromex because it looks like a Pollock painting when it's displayed here, but it will take a bit to load. And this is also really nice because it helps catching regressions, or if something happened on a node or whatever. So this might look confusing, but no worry, like we go into it. So on the right, we have the different systems where it's being run. And let's try to do some filtering here because it's a bit confusing from this So let's say Vega, which is one of the big EuroHPC system, and this looks quite messy, to be honest. So as what we want to see here is to see if everything is fine. This should be ideally as flat as possible, which means that you had the exact same performance every time you run the software. But for example, here we see that something happened. And if you go to check each point, you will see like the details of the run at the time, what time, the results, the system again, the exact module of the software you had been run. And you can also see details for some jobs that failed, and also like aborted ones for some reason. And thanks to this, let's see if it is not flat. For example, see these ones that are flat, this is good. And for the other ones, for some regressions we detected, we actually could like communicate it to the administrators of that site. Because for example, Vega is not one of our machines, and we help system administrators with that. And this is, if you as a system administrator would like to contribute the data of your machine to the EESSI dashboard, you are more than welcome to write to us, and we can see how we do it. But yeah, we are open to host new systems from where to run these tests. So let's go to the EESSI use cases, and I think we're doing well in time. Yeah. Use cases enabled by EESSI, again, the uniform software stack, so makes my life incredibly easier, because a practical case is that I maybe, for example, start to work on some code development on my laptop, and then of course my laptop, it's not an HPC cluster, so I cannot run tests on my laptop. But if then you have to migrate your development to another environment, thanks to EESSI, I don't have to install like all the dependencies again, or if I'm working in a bundle, I don't have to make sure that every single package I'm using, it's like the same version, or any kind of, or not lose time doing that. I just start EESSI and it just works. So good. And now EESSI is integrated as the common open source software stack for the European Federation platform, but I will mention more on that later. It enables portable workflows, just as I explained, and significantly facilitates setting up infrastructure for HPC training. And EESSI is now integrated in Open On Demand. We are in touch with Open On Demand developers. I will also talk about this later. And EESSI can be used in CI pipelines. And we are in constant collaboration with software developers, not of only, for example, we really know the GROMACS developers. We have reported quite some bugs thanks to EESSI, because the good thing about this is because you are testing constantly the same software on very different machines or different kind of environments, so it's really easy to spot bugs. But we also help software developers from like European codes, but also more on that later. If you're interested of using EESSI in CI environments, we also have this webinar in one of the next Mondays. So again, you are more than welcome to attend that. And about the collaboration with software developers and experts, again, this is open source. Anybody can look at it. Anybody can be part of the EESSI dashboard. So it's really easy to spot things that are going wrong. So we work with software developers and experts to verify their installations and check how everything is configured and built, and help to see if the software is functional in different use cases. Also, again, do this automatic extensive testing, also to evaluate the performance and see if there is any regression, maybe with some updates or changes they have done. And also some developers themselves provide the EESSI build recipes to be contributed to EESSI, so super nice of them. And again, it really relieves the software developers to having to install every single new release they do in all the machines, and having to install everything, and or having to bother the system administrators or anything. You just put it to EESSI and you have it available in such a different kind of environments. But I will go into more detail later. Another resource where you have EESSI available is through the European Open Science Cloud, which is just another way to ask for computational resources through the European Union. So basically, if you have resources there, if you know about it, you can access to the EESSI compute node where you will have EESSI available and use the software there. We have the publication on how to use it through the EESSI blog. You are free to check it too. And the European Federation platform, it's this unified way it's a really recent project / release. Like, it's this really new way to, again, find the same thing everywhere you go, because every EuroHPC center, it's different and implements things on a different way. But thanks to the European Federation platform, the access is more uniform, and not only on software, just like EESSI, but also like through doing some workflows or through interactive jobs, or on the way to ask for allocations. But this is a complete whole other topic. You can check everything about the European Federation platform on this webpage. They have done also a series of webinars recently. They are all recorded and you can check it. And the good thing about that is that it ensures that EESSI will continue to be there, and it will not only be present on HPC, in all the EuroHPC clusters, but also AI factories. And who knows if maybe quantum computers one day. Open on demand, it's what I mentioned earlier. It's this web desktop-based application. So it makes it super easy for people who is not familiar with this kind of like Linux environments, because you usually don't grow up with a Linux machine. People usually uses Windows, and then once they get into an HPC cluster, they get really confused. So Open on Demand really helps with this kind of people who gets confused with terminal environments, and this provides a GUI to them. So the integration that's there, it is EESSI General app, where you basically just click. You will see the list with all the available software. You just click on which modules you want to load, you launch it, and then you will have a desktop open for you with this software available. So super nice for beginners to this kind of environments, makes life easier. So moving on. About dev.eeessi.io, this is the development repository. As you saw, we have the production one, which is like for permanent installations. If it's installed through the production repository, it's meant to be there forever and not be touched, unless we really have to update something for some critical update, like security problems or something. But they are not meant to be touched. They're there, and that's it. But thanks to dev.eeessi.io, this is another tool for software developers. So software developers can do temporary installations there, and they can install software from commits or add patches in case they need to. So it's like a much more dynamic repository. And maybe you as a developer want to skip some CPU targets because you might not be interested into building for absolutely everything architecture out there. You just want to test something. And dev.eeessi.io is built on top of the production one, which means that you can take all the dependencies from the production one and not have to worry about also installing everything on the development one. And it's organized in a different way, so they are organized by project. And for now, there's only available this service. It's only available for the codes within the multi-skill project, which is the one that funds EESSI. But if you want to put your code in there to test it, then just talk to us and we can see what we can do. But it's really, really nice for software developers, especially the ones with access to your PC machines, because it's like you want to test a new feature from your software, you just open a PR, and if everything goes fine, within minutes, you will have it available in all these kind of different super big machines for you to test it. And there's another new thing, which is the EESSI, which is a new command line interaction, command line tool to make access to EASY even easier. It's still a work in progress. There are just a few commands available, but it's maybe nicer if I also show it from my laptop. So, and it's installed through pip install easy, just like that. But I already have it, so nothing changed here. But yeah, it's in PyPy. It's as this is installing that, and if I now do easy check, this is just kind of the same of the status.easy.io page I showed you. It shows that all the repositories are fine, that the mirror servers are available and everything. And then there's this other way to access easy in case you don't want to do the source /mbmfs or whatever is your blah 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 blah. You can do it in shell and then specify the version. Okay. And this is a bit more verbose, but basically it again initialized the easy. And if I now do level, it's just as I showed you before, but this makes it easier in case you don't want to do all the source, blah, 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 blah. And it's much nicer to interact with. So this is quite a new thing. You have it there, more things to come. It's a work in progress, but it's really nice. And there's also this very cute update on the available software page. It used to be a bit difficult to read, but now it's super nice. So let me show you too. If I go here, I will see all the software that's available in Easy and like the count on how many things you have. So in case, again, I want to check if the software I want to use is available in Easy, I just type here, I don't know, Gromax, which of course will be there, and I can see easily an overview of in which Easy versions it's available, for which CPU families it's supported, and for which, in case it's GPU enabled, I can also see it from here. And if I enter the page, you can see like the specific versions, the architecture for which is supported. And for this case, we see the GPU enabled version, which compute capabilities it's supported to, and the very particular module name for you to then just load it right away. So super, super, super nice. And I mentioned a few times our blog. We really also invite you to check it because it has, it features updates that we have done, some nice things from Easy, conferences or events that we are attending or that we are organizing. So please visit it. And I guess that would be most of it, of the theoretical part. So I'm going to do some conclusions here. Again, you have to, the takeaway from today is that Easy, it's this unified software stack of on-demand stream optimized scientific software installations. It works everywhere, no matter the Linux distribution, the architecture, the platform, anything. It will work everywhere, and that it's community oriented. So it's an open source project. Everything you have seen today, it's open, completely open. You can check the software layer, how it's implemented. You can check the compatibility layer, how it's also implemented and orchestrated to installed. You can check everything. So let's work all together to make Easy bigger and better. And EASSI won an HPC Wire's Reader's Choice Award. That was 2 supercomputings ago. It's crazy how time flies. You can read the full news on our blog, and it won the best HPC programming tool or technology category, and it's the Reader's Choice Awards, which means that people voted. So thanks to everybody for that. And we do quite of a big community dissemination work. So you probably will see us in every conference we have a chance to speak. These are just some of them, and there's also Spotify podcast where I talk, and I don't like listening to myself, so I don't even listen it. And last week, there was the most recent is the EasyBuild user meeting, which was last week in Guimarães. You can check the webpage. The talks are it had a day dedicated to EASSI, and you can check the talks that were given. They're also recorded and the slides uploaded, so you can check it. And there's also a support portal dedicated to anything you might need. You can access it either through GitLab or through or just send an email to this direction. That's thanks to the multi-scale project that we can have this dedicated support team, and it doesn't have to be support in terms of problem solving, but you can also like ask questions, you can request for additional software, you can send suggestions, you might need help. Like, for example, if you want to adopt EASSI on your center and which is the best setup or the best way, or if you're having problems with that, you can also suggest features. And in case you are shy or there's some confidential information, you can open a confidential ticket. So we wait for your inputs. And you have these best practices for BMFS in HPC tutorial we did some time ago. In case you want to adopt EASSI in your center, here you will have some tips and tricks and recommendations for you to have a smooth adoption. And there's an EASSI paper, which is quite a bit oldish now, but it's still nice to check. It's a performance comparison between different systems, where EASSI binaries were used, and also like binaries from the installed by the administrators there. You can check it. It's linked here, open access. And these are all of our socials. You can check the website, the GitHub. Again, everything is open. Documentation is very much complete and up to date. The blog is really nice. You are more than welcome to join the Slack in case you want to interact more swiftly with us. And then I think every single webinar tutorial that we have done, you will find it in the YouTube channel, the paper, the support portal, and there's also the bi-monthly online meetings. So every first Thursday of the odd month at 2 p.m. there's this status report online meeting kind of thing where we explain all the developments they're having through this month, well, the last month. And you are again more than welcome to join. Doesn't matter if you are just a beginner, if you just want to sniff a bit what's happening, everybody's welcome. And then there's the happy hours. And right now they are on hiatus because we are doing these webinars on the same exact hour, but it has been a very long weekly meeting where there was a tiny presentation of some aspect of EASSI, and then there was an informal discussion or questions asked, or sort of like a closer interaction. And again, they are stopped right now until the webinars end, but you can check all the older sessions in our YouTube too, because there are interesting presentations for everybody. And these are the multi-skill socials, which is again the project that funds EASSI with all of its partners. You will find us everywhere: webpage, Facebook, Twitter, LinkedIn, and Blue Sky. And I think I am even faster than in the rehearsal. I hope I didn't speak too fast and the demos got through. So Again, this is the first webinar. We wait for you for the next ones. So I really don't know how it went that fast. That means that we have a longer Q&A part. So thank you for listening to me.
Thank you, Helena. I think the pace was actually pretty good. You didn't go too fast, in my opinion, and you covered a lot of ground. So thank you very much. Let's see if we have a couple more questions, so people can preferably drop their question in Slack, or if you want to raise your voice yourself, you can raise your hand here in Zoom. Be aware that we still have the recording going. But any questions are definitely welcome for Helena.
Yeah, I have to check it through my phone because I'm...
It's okay. We can raise them to you. There was somebody who asked a question in Slack on mounting ServMFS through a container using Docker. So if that is possible and how that is done, it was mostly answered in Slack, so I won't go over the details here. You can do it with Docker as well, but you have to do a privileged mount because you need to be able to do a fuse mount of the ServMFS repository. So it's a bit tricky, but it's definitely possible. And if people want to hear more about this, please check the channel in Slack, and there's a discussion going on there below that question in a thread with some very good information. Okay. Beyond that, I don't see any questions coming in, Helena. Nobody's raising their hand as well. I consider that a good thing.
I also think so.
I guess, you covered a lot of ground, and maybe people need some time to look into the details. But it looks like most of what you've explained was very clear. So, yeah, I think that's very helpful.
Nice. Okay,
I see someone still typing away in Slack, so maybe there's still a question coming. One small correction, and the EFP developments are going fast as well. EESSI is now actually natively available on Discoverer as well through ServMFS, so you don't need to use CVMFS exec or anything like this anymore. And that's actually also in Meloxina, it's there by default, at least if you start jobs. So it's not there on the login notes, but it is if you start a job. They are not doing a native CVMFS installation. They use Squash FS images and mounting, but as an end user, you don't really notice that. So yeah, but that's developing quite fast. Okay, I don't see questions coming in. Of course, if people do have questions after the fact, they're welcome to reach out in Slack, especially in the webinars channel or anywhere else in the EESSI Slack. You'll find very helpful people. There is a question here in the Zoom chat. Are the benchmarks showcased here? Are they specific to each software application or the EESSI software builds? So I guess this is on the dashboard that you showed. The question is, are they specific to each software application or the EESSI software builds? Yeah,
the EESSI software builds.
Yeah, they are indeed for specific software, as you can see, like Romex, CP2K, and these type of things. They are actually not very specific for the way in which we install the software in EESSI, although everything here, I think, was actually run via EESSI. But as long as you have the software installed via modules, which were installed through EESSI Build, so there is that assumption, you can actually run these tests on your system yourself. And some people are doing that. So take a look at the EESSI documentation, look for the test suite, and it actually has very detailed documentation on how to run the test suite and how to collect these type of results as well. Yeah, and we're getting a thumbs up for that. So that's like a useful answer.
I think there was somebody typing, but I can't see anything.
Yeah, the question isn't coming through, so maybe they're still working on that. That's fine. That was in Slack, so they can ask that question at any point. Okay, then I think, Helena, we can wrap up here. Maybe you can show the slide again for the upcoming webinars. So maybe you have registered already for the upcoming ones. If not, you can still register for the later ones coming up. And if you have any trouble with that, please, again, just raise a question in Slack or contact us via support@eeessi.io. And we're more than happy to help you if there's any trouble there. All right, and with that, I think we'll close the session here. I'll at least close the recording. If people do want to raise their voice after we close the recording, they still can. Thank you very much and see you next week.
Thank you.